In the vast expanse of our solar system beyond the familiar planets lay a mystery that captivated astronomers for decades. A faint, elusive presence hinted at the existence of a ninth planet, dubbed Planet X. The search for this celestial phantom consumed countless hours of observation. Irregularities in the orbits of Uranus and Neptune suggested an unseen celestial body. Armed with this clue, astronomers embarked on a relentless pursuit. Their pursuit led to a discovery that challenged the very definition of a planet. In the year 1930, a young astronomer named Clyde Tombaugh toiled away at the Lowell Observatory in Flagstaff, Arizona. Tasked with the daunting mission of finding Planet X, Tombaugh spent countless hours meticulously comparing photographic plates taken of the same region of the sky at different times. His tireless efforts paid off on February 18, 1930, when he noticed a faint point of light that shifted position between two images taken 6 days apart. The discovery sent shockwaves through the scientific community and captured the imagination of the public. Here, at last, was the long-sought-after Planet X, a world lurking in the frigid outskirts of our solar system, billions of miles from the Sun. The discovery was hailed as a triumph of human ingenuity and perseverance. The newly discovered world was named Pluto. The name, drawn from Roman mythology, seemed fitting for a celestial body residing in the dark and distant realm of the solar system. Pluto, the god of the underworld, ruler of the unseen and mysterious, became the namesake of this newly discovered world, a fitting tribute to its elusive nature. As astronomers began to gather more data on Pluto, it became clear that this distant world was unlike any other in our solar system. Its orbit, for instance, was highly eccentric, meaning it deviated significantly from the circular paths of the other planets. Pluto's orbit was also highly inclined, tilted at an angle of 17 degrees relative to the plane of the solar system, further distinguishing it from its planetary siblings. Pluto's size also set it apart. Initial estimates suggested that Pluto was roughly the size of Earth, but subsequent observations revealed that it was actually much smaller even than our own moon. Its diminutive size, combined with its unusual orbit, raised questions about Pluto's true nature. Was it truly a planet, or was it something else entirely? Pluto is only about 1,400 miles wide and has no rings. Despite its small size, Pluto possessed a retinue of moons, further adding to its enigmatic nature. Charon, Pluto's largest moon, discovered in 1978, is so large relative to Pluto that the two bodies are often referred to as a double planet system. This gravitational dance between Pluto and Charon, locked in a perpetual embrace, hinted at a complex and fascinating history. The discovery of Pluto in 1930 marked a pivotal moment in our understanding of the solar system. Here was a ninth planet, a world residing in the distant icy reaches of our cosmic neighborhood, a testament to the vastness and diversity of our solar system. However, as astronomers gathered more data on Pluto, its status as a planet came into question because of Pluto's small size, its unusual orbit, and its location in the Kuiper Belt. Kuiper Belt is a zone beyond the orbit of Neptune, a region populated by hundreds of thousands of rocky, icy bodies. Some astronomers argued that Pluto was simply too small and too different from the other 8 planets to be considered a true planet. Others countered that Pluto's historical significance as the 9th planet, along with its retinue of moons, warranted its continued classification as such. The debate surrounding Pluto's planetary status was not merely a matter of semantics. It was a fundamental question about how we define a planet, about the criteria we use to categorize celestial objects. It was a debate that forced us to re-examine our understanding of the solar system and our place within it. In 2006, the International Astronomical Union made a historic decision. They reclassified Pluto as a dwarf planet. The decision was based on criteria Pluto failed to meet. A planet must orbit the Sun, be spherical, and clear its orbit. Pluto's orbit overlaps with Kuiper Belt objects. This reclassification highlighted the diversity of our solar system. Pluto is now recognized as a dwarf planet, along with Eris, Makemake, and Haumea. Pluto's surface is a realm of frigid extremes, sculpted by a distant sun and a tenuous atmosphere. Pluto is about 3.6 billion miles away from the Sun. One day on Pluto takes about 153 hours. Temperatures plummet to minus 370 degrees Fahrenheit, freezing nitrogen, methane and carbon monoxide into solid ice. These ices form vast plains, towering mountains and intricate networks of canyons and craters. The surface of Pluto is extremely cold. The extreme cold renders it inhospitable to life. Water, a fundamental component of life, is permanently frozen in a solid state due to the planet's low temperatures. Although Pluto's atmosphere is incredibly thin, about 100,000 times thinner than Earth's, it is remarkably complex and dynamic. Composed primarily of nitrogen, with traces of methane and carbon monoxide, Pluto's atmosphere is thought to exist in a delicate balance, constantly replenished by ices sublimating from its surface while simultaneously escaping into space. As Pluto moves along its elliptical orbit, its distance from the Sun varies significantly. When Pluto is closest to the Sun, its surface warms slightly, causing ices to sublimate and replenish its atmosphere. As Pluto moves farther away from the Sun, its atmosphere begins to freeze out, collapsing onto its surface as a thin layer of frost. This cyclical process of sublimation and condensation creates a dynamic and ever-changing atmosphere on Pluto, one that is constantly interacting with its surface. The presence of hazes in Pluto's atmosphere, detected by both ground-based telescopes and the New Horizons spacecraft, suggests that complex chemical reactions are taking place, producing organic molecules that rain down onto its surface. Pluto is not alone in its lonely journey around the Sun. It is accompanied by a retinue of 5 known moons, each with its own unique characteristics and story to tell. Charon, the largest and most intriguing of Pluto's moons, is named after the ferryman of the underworld in Greek mythology, is tidally locked to Pluto, meaning that the same side of Charon always faces Pluto, just as the same side of the Moon always faces Earth. This gravitational embrace between Pluto and Charon has profound effects on both bodies, influencing their rotation, their tides, and even their internal structures. Pluto's other 4 moons, Nix, Hydra, Kerberos, and Styx, are much smaller than Charon. 4 moons are much smaller, less than 100 miles wide. These smaller moons are thought to be captured objects, asteroids or comets that strayed too close to Pluto and were ensnared by its gravity. The study of these smaller moons can provide valuable insights into the formation and evolution of the Pluto system. In July 2015, after a 9-year journey, NASA's New Horizons spacecraft made history by becoming the first to fly by Pluto, providing humanity with its first close-up views of this distant world. The images and data revolutionized our understanding of Pluto, revealing a world far more complex and dynamic than imagined. New Horizons showed diverse geological features, from mountains of water ice to plains of nitrogen ice, intricate networks of canyons and impact craters. The spacecraft detected a tenuous atmosphere, complete with hazes and clouds, suggesting Pluto is far from inert. New Horizons also provided insights into Pluto's moons, especially Charon. Charon has a diverse surface, sculpted by tectonic activity, cryovolcanism and impacts, evidence of subsurface oceans on Pluto and Charon, suggesting these worlds may be potentially habitable. Pluto, once considered the 9th planet, may now be classified as a dwarf planet, but its allure and scientific significance remain undiminished. The New Horizons mission, with its treasure trove of data and images, has revealed Pluto to be a world of unexpected complexity and beauty, a world that continues to challenge our assumptions and expand our horizons. Pluto's story is a reminder that our solar system is a place of endless wonder and discovery. It is a testament to the power of human curiosity and ingenuity, our drive to explore the unknown and unravel the mysteries of the cosmos. And as we continue to explore the outer reaches of our solar system, we can be sure that Pluto, the dwarf planet with a heart of ice, will continue to captivate our imagination for generations to come. Pluto's story is far from over. The data collected by New Horizons will continue to be analyzed for decades to come, providing new insights into this enigmatic world. And as we develop new technologies and embark on even more ambitious missions to the outer solar system, we can be sure that Pluto will continue to surprise and amaze us.